Hello, students, and welcome. I know your exams are just around the corner, so let's just take a few minutes to do a calm, focused revision of one of the most fundamental chapters in physics, motion. Think of this as our final brush-up session, just to make sure every single concept is crystal clear before you walk into that exam hall.
So, here's our plan for this session. We'll start with the absolute basics of motion. Then we'll dive into the key quantities you'll be using all the time. That's speed, velocity, and acceleration. After that, we'll spend some time decoding motion graphs, because these are a favorite in exams. Next, we'll tackle the famous equations of motion, understand a little bit about circular motion, and then we'll finish with some very important tips to help you do your best in the exam. It's a very clear path to get you fully prepared.
All right, let's start at the very beginning. What exactly is motion? Well, in the simplest terms, we say an object is in motion if its position is changing with time. But here's a really interesting thought. Motion is always relative. You see, if you're sitting on a moving train, you feel like you are at rest compared to the person sitting next to you, right? But for someone standing on the platform, you are very much in motion. So it all depends on your point of view.
Now, to describe any motion properly, we absolutely must have what we call a reference point, or an origin. For instance, if I say my school is 2 kilometers away, that information isn't very helpful, is it? But if I say the school is 2 kilometers north of the railway station, suddenly it makes sense. Here, the railway station is our fixed reference point.
Okay, let's move on to the actual quantities we use to measure and describe motion. We're going to start with two terms that students often get confused with but are actually very different: distance and displacement. You know, getting this difference right is so important for all the numerical problems.
So, what is distance? Distance is simply the total length of the path you have traveled. Imagine walking from one corner of your room to the opposite corner, but you walk along the walls. The total length you walked along those two walls, that is the distance. It only has a value, or what we call a magnitude, like 10 meters.
Displacement, on the other hand, is the shortest path possible. It's a straight line from where you started to where you ended up. It's like taking a shortcut. And here is the most important part. Displacement has both a value and a direction. So you would say something like 7 meters towards the northeast. This makes it a vector quantity.
Now, this image here is a perfect example to understand this difference. Let's look at the journey. The object starts at O and travels all the way to A, that's 60 kilometers. Then it turns around and comes back to point C, traveling another 35 kilometers. So what's the total distance? Well, we just add them up. 60 plus 35, which gives us 95 kilometers. But what is the displacement? For that, we only care about the start and end points. It started at O and ended at C. The distance between O and C is just 25 kilometers. See the huge difference?
This brings me to a very, very common exam question. Just take a moment to think about it. Is it possible for an object to have moved, covering some distance, but for its displacement to be zero?
And the answer is a definite yes. Think about an athlete running one full lap of a 400-meter circular track. When they finish, they are right back where they started. So the distance they covered is, of course, 400 meters. But because their starting position and their final position are exactly the same, their displacement is zero.
You know, this same logic applies to the difference between speed and velocity. Speed is just about how fast you are going, say 60 kilometers per hour. It's a scalar. But velocity is speed times with a direction. So 60 kilometers per hour due north, that's velocity. It's a vector. Just by adding that one small piece of information, the direction, we're talking about a completely different physical quantity. So what happens when velocity changes? Well, that's what we call acceleration. Now here's a very important point that many students get confused about. Acceleration is not just about speeding up. You are accelerating if you are slowing down. We call that negative acceleration, or deceleration. And you are also accelerating if you just change your direction, even if your speed doesn't change at all. We will come back to this important idea a little later.
Okay, let's now look at how we can show all this motion visually, using graphs. Graphs are such a powerful tool in physics, and I can almost guarantee you will see some graph-based questions in your exam. So let's focus on how to read them properly and understand what they are trying to tell us.
Have a look at these two distance-time graphs. The one on the left is a perfectly straight line. This tells us that the object is covering equal distances in equal amounts of time. This is what we call uniform speed. Now, the graph on the right is a curve. This means the distance covered is not constant over time, it's changing.
This represents non-uniform motion, or in other words, accelerated motion.
Now, for your exams, I really want you to remember these 3 golden rules. They will help you a lot. First, the slope, that is the steepness of a distance time graph, gives you the speed. Second, the slope of a velocity time graph gives you the acceleration. And third, and this is the one people often forget, the area underneath a velocity time graph gives you the displacement. So just remember, slope, slope, area. Got it?
All right, now we come to the part that will help us solve all those numerical problems. The 3 equations of motion. I want you to think of these as your personal toolkit. But remember, they have one condition. They can only be used when an object is moving in a straight line with uniform acceleration.
So here they are, your 3 very important equations. The first one, v equals u plus at, relates velocity and time. It's the one you use when you need to find the final velocity after some time has passed. The second one, s equals ut plus half at squared, relates position and time. It's perfect for finding out how far an object has traveled. And the third one, 2as equals v squared minus u squared, relates position and velocity. This one is super useful when you don't know the time.
Let's just quickly walk through an example together. A car accelerates from 18 to 36 kilometers per hour in 5 seconds. Now, step 1 is the most important. You must list down everything you are given and convert the units to SI units. So 18 kilometers per hour becomes 5 meters per second, and 36 kilometers per hour becomes 10 meters per second. Now, to find acceleration, we choose the first equation, we substitute the values, and we solve. And we get 1 meter per second squared. Simple. Then, to find the distance, we use the second equation, put in all the values we know, and we solve to get 37.5 meters. You see? A logical, step-by-step approach always works.
Let's talk about our final concept for today, uniform circular motion. This is a topic that can be a little bit confusing for some. So, the question is, if an object is moving in a circle at a constant speed, is it accelerating?
This picture illustrates the idea perfectly. Imagine you are whirling a stone that is tied to a string. The stone might be moving at a steady speed, let's say 5 meters per second. But if you look very closely at its path, you'll see that at every single point on that circle, its direction of motion is changing. And if the direction is changing, what does that mean for its velocity?
And this brings us to a very, very crucial point. Constant speed is not the same thing as constant velocity. Why? Because velocity is a vector. It has both speed and direction. So if the direction is changing, even if the speed is not, the velocity as a whole is changing. And what did we say a change in velocity is? It is acceleration. So the answer is yes, an object in uniform circular motion is always accelerating.
So, we have covered all the main concepts from the chapter. Now let's just quickly go over some practical tips that will really help you score well in your exam.
Please pay very close attention to these points. First, I cannot stress this enough, always convert units to the SI system. Second, read every question very, very carefully. Are they asking for distance or displacement, speed or velocity? Third, whenever a question says an object starts from rest, that's a hint. It means the initial velocity u is 0. And if it says brakes are applied or comes to a stop, that means the final velocity v is 0 and your acceleration will be a negative value. And finally, for graph questions, the first thing you must do is look at the axes, and only then should you interpret the slope or area. And that brings us to the end of our quick revision. Just remember, you have studied all these concepts very well. Just try to stay calm, read the questions properly, and I am sure you will do wonderfully. All the very best.